Okay, I almost dropped my phone. Okay, hello. So I'm working on setting up some of the stuff right now for my homemade snow coefficient of friction lab. Now, I was planning on starting up there somewhere, but as you can see, or maybe can't see, I can't even see what I'm filming. There's some deer tracks in the yard, so I'm gonna try to find a good flat space without too many steps. Like, I see, which I also can't see what I'm recording, so, but there's a few, looks like right there, which I think there's only a few there, so it shouldn't be too. There's a lump right there, I see that. I might be able to blow right through that though after like a test run. Or I was thinking I could start a little lower. Like I could start down there. It looks pretty flat and straight right there. And I bet I can get the angle pretty accurate if I start there. Okay, this is just part one. I'll make a part two or something later. And I also can't see what I'm recording. Okay, 1.5 minutes for a first part of the video. Hopefully I put them all together and know how to put them. Okay, I'm working on starting or finding a good starting point right now. And the problem is I'm having trouble getting to the actual hill part without falling. So I'm just gonna show the materials real quick that we got. Notebook. I'm gonna write down data and scissors and duct tape we're gonna use to keep the box closed. Got a pen in here too for writing the notes and the data down. And in here we got weights, which I'm gonna figure out later to put in the box so it slides down properly and also doesn't sink in the snow. But I'm gonna figure that out in a little bit. But what I want to figure out right now is where I want to start on the hill and how I'm gonna get on the hill without falling. So we'll get more on that in a little bit. Okay, this is part 3 update on my homemade physics lab. My sister helped me choose a place where we wanted to set the box off to slide down the hill. We drew a little line right there. I can kind of see it. I can see my shadow a little. And then there's a small bump right here. We're going to avoid that big bump over there. But that small bump right there, I think in a few test runs we can get rid of it. Because before we start using the stopwatch, we're going to slide it down a few times, make sure there's no problems. And now what I'm doing next is I'm going to use my physics toolbox app on my phone to find the change in height from the bottom to the top, which will be important in the math later. Okay, this is going to be the 4th update, I think, of my homemade snow coefficient of friction homemade lab. I feel pretty confident with the height I measured with my app. Not so confident with the angle right now. I'll see if I can do anything more accurate, but after I figured out a few glitches with the altitude measurer thing, I feel pretty confident now with the starting height. So I'll be back, I guess, in a bit with another update after I think what to do next. Okay, this is update 5 on my kinetic coefficient of snow friction homemade lab. I got a better angle measurement. Well, I got multiple angle measurements. I got 10 of them. I'm going to take the average of that to hopefully get a more accurate angle than just picking 15 and guessing. So I'm going to actually take an average now. We got little boys on the kitchen floor. That doesn't have to do with the lab. but I thought I'd give him the spotlight for a second since he's trying to untie my boots. Okay, I'll get more updates later, and when we actually start testing, sending the box down the hill. Okay, this is part 6 of the lab. I came up with what I think is a more accurate angle. I got some more data tables set up, and now what me and my mom's home now to help, we're gonna go out and find how much weight we want to put in this box, and then we're gonna put it on a scale, and I'm gonna do some math before we go back out and start timing it. Is it on? Yep. Alright, so we're gonna test this. We're gonna try to use a plate. Maybe not the best thing I would have wanted to use. I'm slipping. Okay. So I'm gonna test this, go send it down, and if this looks good enough to me, I'll go weigh it, and then we'll start the actual timing off. Oh, see, that's gonna go off the box. Oh. It might not matter, actually. Alright, so, we have all the data now. Some things, I didn't mention it in the test run, but we did end up not using the box with the weights in it. We couldn't get that to slide. We ended up using these little plastic plates, which might not be as accurate. We did have 4 of them. I did think about stacking them. We decided not to stack them, to save time, with me having to go up and down the hill less. Yeah, so ran out of ideas I wanted for this part. Yeah, we could have got more accurate results maybe if we stacked the plates, but we just did it to save time. We'll see if that messes anything up. Okay, I'm ending this one right now. Okay, this is going to be the final part of my lab video, my homemade lab, and I did get a value for the kinetic coefficient of friction of our snow, and I'm really happy with it. It was close to the range Google gave me, which I was happy with. It was within the range Google said it could be. Alright, I'll show some of the math right now. Okay, as you can see, we took our 10 closest times, took the average of that to eliminate random error, because the AP people, the AP test graders love to hear that. Okay, this distance I just used trig for. Yeah, we were originally gonna do the box. It didn't end up working. The plate, that was the weight of the plate in newtons, which I got the mass in grams, then kilograms, then newtons, just multiplied by little g. I used this right here, which this is from one of the 4 basic kinematics equations. I didn't write the original. I guess I'll write real quick. It's yeah, so I use this kinematic equation. The original velocity was 0 because we just dropped them down and they slid down the hill. So that's average velocity, which we just canceled out the original velocity. We ended up getting this for the average final velocity from the average time. Tried to do a little AP style free body diagram right down there. Not the neatest. Here's how I found a normal force. I just used this and used more trig, which I knew that equation, but I tried to do the little AP style free body diagram because they also like that. I'll turn to the next page of math. It's over a little. Okay, so here's where we put it all together. Here we have the original potential energy, gravitational potential energy from the height we drop the plates. And then there's the work done by friction. I wrote energy lost in quotations because I blanked on the word converted, because converted's a better word, because energy can't be created or destroyed. And that there's the final kinetic energy. Put a little smiley face down there, so it lined up. There's a work equation, FD cosine theta, and for the friction is what we use it for, which the friction acts in the opposite direction of the displacement. So I pulled a -1 there and rearranged this equation. Moved the work over because it's minus with cosine, and I moved the kinetic over, turned into this. There's a friction equation, and that's the distance for work. And it worked out perfectly because the final kinetic was less than the original gravitational potential. And then I went down here, plugged the numbers in, and I got this value for the kinetic coefficient of friction, which I'm like, okay, it's a positive number. That's a great start. And then I looked up on Google what a range could be, and it was in that range of possible values. Google said from like 0.02, but it could be up to 0.3, which even that I was happy with because I was in that range, which I mean that I'm happy enough with that. Thank you, everybody.